It's gonna be mind blowing. Okay.
This is gonna be hard.
No, you're gonna love this. All right, let's roll. Where is Christian? You doing that? All right. All right, we're gonna take a few notes here. If you guys would write this as your title to the section down, that would be awesome. Where are we in life? We're still in this unit. We're still talking about exponential, and we're talking about logarithmic things, right? These functions, these new functions. Already, you should be really good at graphing exponential functions and using properties of exponents and identifying exponential growth and decay and transforming these functions. And now you also know what a logarithm is, how to evaluate logarithms, how to graph logarithms. Maybe. I mean, that's my hope. I don't know. But now we're going to turn our attention to solving exponential and log equations, something we haven't done. Even something as simple as this first example, right? We haven't showed you yet, even though it looks not too bad, really. You don't have the tools to solve it. In fact, why don't I give you a second? Everyone see if you can just make a guess, or do, just by inspection, see if you can solve that equation. Take some guesses and see what X is. I'll be very impressed.
What is it called? Solving exponential.
And log equations. So by solving exponential and log equations, I mean equations like this. Equations that have exponents in them. Or logs in them. Anyone have a guess? Try some X values, see if they work. It's not easy, right? I just... Anyone have one? Try some numbers. Does it work? Is X equals 1 work? I don't know.
Oh.
Maybe I don't see anyone like jumping up and down. So maybe we need some more like robust strategies to attack this problem, huh? Aren't you dying to know how to solve a problem like this?
Yeah.
Aren't you dying to know? Yes, thank you. There needs to be a thirst in my learners, okay? Because we can't just move on and pretend like we don't care. We gotta care. You gotta want this answer. What do you think? You found the answer? All right. Well then, put a lid on it for a minute. Okay. Let's see if we get the same thing you got. Okay. I'm gonna ask in a minute. See if you got the same thing I did. All right. Just for fun, I have no idea what this is gonna be useful or not. I know it's like all in my way. 2 to the x equals, just for fun, I'm going to rewrite 4 as 2 squared. Is that okay? Can I do that? If 4 walks into a party, it can wear the name tag 4, or it can wear the name tag 2 squared. Same difference, right? Now, again, maybe you don't know why I'm doing that, but do you agree that I can do that? 4, anytime I see 4 in life in general, anywhere in life in general, I can replace it with 2 squared. And then I'd like to ask you about this guy right here. What happens when we have a power of a power? What do we do with powers? Yeah, so what is this power going to be? I claim it's going to be 2 to some power. What is 2 times x plus 1? Yeah, and be careful. I would bet any of you any amount of money that someone will write 2x plus 1 right here when it comes time for the test. Okay? Make sure you distribute is the key word. Distribute the 2 to both the x and the 1. I mean both. I'm doing it both. Can the answer be both?
Yes.
Okay. Okay. I mean, my gesture fun sometimes lead you in the right direction. Okay. All right. Now I need to come over here and put something in a box. Okay. All right. If you have, I want to have this little discussion with you. If I told you that 2 to the a was equal to 2 to the b, right? Like I have a number I'm thinking of, and I'm going to do 2 to that power. And Miss Sarah, she has a number, and she's thinking of a number of her own. And she does 2 to that power. And lo and behold, we get the same result. I did 2 to the power of whatever I was thinking. She does 2 to the power of whatever she was thinking, and we get the same number. What do you think must be true about our original numbers? Any idea? if this is true, what do you think is true about A and B is my question. Yeah, I mean, it's not meant to be a trick question. It means that our two original numbers were, there's no other way. Like if she got 32, then I know her number that she started with was 5, right? That's not, I want you to make sure you appreciate that. That's not always true in math, right? Like if I think of a hidden number and you think of a hidden number, I'm gonna square my number. Are you ready? Squared. I got 25. What would my number be? Does it have to be 5 though? It's actually not what I was thinking. Yeah. I was thinking of -5. So you see, it's not necessarily true. But in this particular case, right, if 2 to the A, if that's like 32, then I know you were thinking of 5. There's no other way around it. There's no other way around it. It's not like 2 to another power gives you 32. Only 5. So if this is true, this is necessarily true. Likewise, it goes in the reverse too. It's biconditional. If this is true, then this is true. If this is true, then this is true, right? All right, so now I claim that we're in that situation. Come over here with me. We have 2 to the something equals 2 to the something. What must be true about the somethings? This. And this. They've got to be the same. Do you agree, Alan? All right, so I'm going to write this down. This is a little weird, though. Is that okay? Do you agree with this result? If you really agree with what we were saying, if 2 to the A equals 2 to the B implies that A has to be B, then that's what I'm writing over here. It's kind of like the 2's cancel out. I definitely don't want you to say that like on both sides we're dividing by 2 or something. We're not. We're not doing that. There is something we're doing on both sides, but I'm not going to tell you what it is because I'm me. Okay. But I want you to just have it make sense in your mind. Does it? I mean, if we have 2 to the something equals 2 to the something, well then the somethings have to be the same. And if you agree with that, then the rest is not hard. Right? You can give this to your little brother in Algebra 1. Ready, go. Just solve that. Tell me what you get.
It's just an equation. It's an equation, obviously, and you're solving for.
So do it. Anyone? Well, you're going to have to combine the terms on one side or the other, right? So you have to maybe start by subtracting one of those things that has an X in it on both sides, right? Is that okay? Any better? Did you get it? What are you going to do on both sides? Subtract what? 2. You can subtract 2 on both sides. Eventually we have to deal with the fact that there are 2 x's in the picture though, right? So yeah, you could maybe subtract 2x from both sides. You could also subtract x from both sides. That would also be fruitful, but the point is we don't like having 2 x's and we want there to only be 1. So yeah, maybe we subtract 2x on both sides. Over here we'll get, what's x minus 2x? Negative x. And over here the 2x went away, yay. What is x? Maybe multiply both sides by -1 or divide both sides by -1, whatever you like. X equals -2. Now there's a reason that this is hard to do just by looking at it, isn't it? It's because the answer was x equals -2. Let's just verify that this in fact is the correct answer. Is it true? I would like you to figure out, is it true that 2 to the -2nd, figure out what that is that the same thing as 4 to the -1st, if I put -2 up here? Plus 1, -2 plus 1 is -1. So is this the same thing? What's 2 to the -2nd? Somebody help me. 1 over 2 squared. Okay, yeah, 1 over 4. And is 4 to the -1st 1 over 4? Yay. Isn't this thrilling? I told you it would be. Where did Alan go?
I guess it was too thrilling for him.
Alan, where are you? You're missing it, man. Where did Alan go? Alan, where are you going? Hey, you gotta ask me, man. You gotta go to sleep and then you're gonna make me sleep? Come back quick. Go, take a break. Go, come on. You don't wanna miss this. Okay. This is good stuff. Somehow you can make it through like a 3-hour concert without going to the bathroom, right? Like, I got a good seat though, up front. All right. Where you go? Let's see if we can do this one. Stepping it up a notch, though.
Follow the steps that you did before.
A little trickier. Stare at it for a second. See if you can have an epiphany. Do you know what an epiphany is? Yeah. Like, we want lightning to strike, so please, make it happen. You giving up already? Anybody have a stroke of insight? Where's the necessary? I need it. I do have a ready hint for you if you need it, but I don't think I'll give it to you yet. No.
Except.
Good work. Now try it. What are you doing now? Again, you just. Yeah, but I mean, how do you get this from this? Well, they're not bases for the same problem. That property only works if the bases are the same. Yeah, we need the bases to be the same to use that power trick. Yeah, right? So.
All right.
Let me just say this, and I'll let you get back to work too if you want. But one could, if one wanted to, one could rearrange both sides to be the some power of the same base, right? Does that make sense? You could rewrite both sides using the same base. So, I mean, re-express both sides as the power of, as some power of the same number. The x plus 1. So the big aha moment that people are having is what? What are we saying? That 4 and 8 are both nice powers of 2. What gives us 4 over here? 2 to the 2 over here is another name for 4, and 2 to the 3 is another name for 8. Okay, is that good? Is that good? Keep going from there. You're gonna have to work with it. That might be the trick.
Follow the steps in your first example because that's going to help you.
That's the trick. Yeah, you may do that, absolutely. Yeah, the temptation I think I sometimes see is people like want to like write 8 as a power of 4. That's harder. What we're doing here is going to be easier. 4 squared is 8. No, it's not.
Oh, really? It's not as an over 1. We think it is.
2 to the... Who's going to help me out here? What do we have as the power on the left side? Was it 2 to the what? 6x. And over here we've got 2 to the 3x plus 3. Yes, good. And then now are we ready to make the big power play? We got 2 to the something equals 2 to the something again. So those things, what do we write, Jeff? What can we write? If we have 2 to the A equals 2 to the B, then it must be true that exactly, right? And now that equation is not too bad to solve, so finish it off. Keep going. What do you get? What do you get? And then quickly verify that this one, actually, you know what, guys? This one you probably could have done without doing the algebra, maybe. Is it true that 4 to the 3 is the same as 8 to the 2? Is that right? That 4 cubed is the same as 8 squared? Is that right? Yes. Right, so I just did a little mental check and just checked it, and it does work in the original equation. Yeah? Good? Good. Okay, not too bad. So far, so good. But Jennifer's still not impressed, so we got to keep going here. Okay. Yeah. All right, try this one now. Notice that our notes basically consist of like a bunch of problems there. Okay, that's okay. That's what we like. Blank slate. That's all. We'd love to get to a place where we can use that same property, right? Like the same kinds of techniques we've been using. But this one is like terrible looking. Isn't it a little bit? Can you clean it up? What might you do first on both sides? Please don't give away any other steps though, okay? Because we want to let people try it here a little bit. What might be your first step, you know? I'll let you think about some. Remember, we're still solving an equation. We'd like to get x like out of the mire that it's in.
Okay, wait, you add 50.
Yes, I think a good strong choice for a first step would be to add 50 on both sides. Don't give away any other steps though. Let people think. Did everyone add 50? All right, now I'm ready for someone to give away the next step if someone has a good idea. I think dividing by 2 is a good choice. Is that okay with everyone else? Is that clear in your minds too? You and you and you and you and you. Yes. Is it clear that dividing by 2 is a good choice? Again, we're kind of thinking like we always do, like about reverse order of operations, right? You got this from here? Yeah, go for it. Okay, say what it is. Okay. And then Nathan take us home. Okay, so what do we say? No, this is like going back to that. What was it? It was like 2 to the A equals 2 to the B, right? Therefore, A equals B. Do you remember us saying that? Can you apply that here? What would have to be true? Okay, go back and look at those again. Well, careful. Yeah, so it doesn't have to be true that, yeah, x plus 7 equals 2. Good. So therefore x is, you want to finish it off? Is that what you guys got?
Yeah.
You and you and you and you and you and you? Okay. Your mind is blown now? Sweet! Okay. Put it, it's up, it's good. Oh, well, you're not going to want to miss this next one, Jonathan. I mean, if you,
No, that's fine.
I mean, you search your own heart. If you were Marcelo, I'd say no though. Okay. He's not here though, so we can make fun of him. All right. Yeah, great. Oh, oh, that's true. He's gonna listen to this. Is he? No.
He's at home.
Is there a way to just put, if once you added 50,
Mm-hmm.
if you would add 50 and put on both sides, put 2, if you put negative 5 on top of there, wouldn't that be 2?
Dude, negative 5?
Yeah, for the exponent. You have to still divide by 2.
I'm not sure what you're saying exactly. The way we did it is really the way to do it. I don't know of another great way to do this problem.
Okay.
Yeah, think about our viewers at home. No, you can. You can no one's watching this. Don't worry. Ask whatever you want. Okay. All right. How about this guy? We've just gone from one that was like looked complicated, but actually you navigated it pretty well, actually, to one that looks really deceptively simple, but actually you're like, oh wait. Am I right?
Yes,
2 to the x equals 7? That's kind of mean, Mr. Chase. You sure you didn't mean 2 to the x equals 8? Or 2 to the x equals something else nice? We've actually asked this kind of question before, right? Maybe you can make a guess. What is x? Approximately, it's not nice, I agree.
Oh.
It's what? It's like opening day this, well, a little while ago when we were first talking about some equations like this. Do you have a good way to do it? What is it going to be approximately? Like I said, if it was 8, I'd be really happy because the answer would be, if this was 8, the answer would be 3. What do you think it is? It's somewhere, it's like 2 point something, right? Yeah. Does everyone have that, at least that intuition? All right, I need to bring back something else into your mind, okay? Are you ready? Insert mini lesson over here. Something to the something equals something. That's called exponential form. We said when we first started talking about logarithms, what? Logarithms? Yeah, here they come, okay? We said that we could write anything in exponential form or equivalently anytime we want in log form. So someone do it for me. Do you remember how this works? Can you write this exponential form instead in log form? It'll be log base what?
X.
Look up here.
Square.
Square, log base square of circle
Equals triangle.
equals triangle. You had something like this on your quiz, right? Where I just gave you exponential form and said, hey, rewrite this same thing in log form. Or vice versa. Here's something in log form. Can you write it in exponential form for me? And for up till now, it's been kind of a fun, cute activity, hasn't it? But right now we need this, okay? So we can go anytime we want. If you see one of these, you can write the other. Anytime you want. So, I don't know. What might you do here? Right now we have something in exponential form. Something to the something equals something.
Oh, we got to write it in log.
So how would that go? If you want to write it in log form, again, just for fun, let's see what happens. Log base what? 2 of what? 7 always equals the exponent, which is x. Logs, remember, logs are exponents. Okay? And in fact, oh, what up? We're done. Aren't we done?
Yeah.
I mean, isn't the goal to solve for x? And by solve for x, I mean get x all alone on one side, right? So we're actually done. Now, I hear you cry. I still would like to know what log base 207 is. And I feel for you, okay? So maybe let's work that out. What is log base 207? How do we figure that out on the calculator? Yeah. You got it, and you got something on your calculator. What is that? It's approximately,
2.80,
just like we expected, 2 point something, 80,
735.
7, etc. Okay, that's good. So x is approximately equal to 2.807, and we can have as much precision on that answer as you like using your calculator, okay? So feel free to use log of 7 divided by log of 2, or we also said you could do natural log of 7 divided by the natural log of 2, whatever you like, using the change of base formula. Cool. Yeah, so we were right. It's 2 point something. Is that cool? Are we still blowing your mind? I just want to make sure you emphasize again here. The first logs were kind of a fun little exercise. They were cute. But now, like, that's the way I have for you to solve this equation, right? Like, that's, you understand? Let's maybe go here. Or at least be able to go here, right? I want you to know how to do this, for sure, okay? I think you're more satisfied with this answer, too, because we kind of have a hunch that it's between 2 and 3, and this kind of confirms that, right? So, moving smartly along. Let's try another one.
Do we have to put this into a log?
Maybe, I can't say one way or another yet.
Oh, wait.
I have to let you struggle for a minute. Just how we do.
Hard. Is that first step? That is all we have.
Yeah. What's the first step? What did I do? Did everyone do that? At least? All right, keep going.
How about that?
That's 7.
Oh, I just copied off of Jennifer.
Well, you're the math man. Math is what I do. I have so many scribbles on here. What? Oh, I'm so funny.
Keep going. Hmm. 10 to what power is 17? I'm wondering, you know. Yeah, what is it going to be? It's something.
Bro, that's not that close. I kind of wish it was 16.
No, it's not better.
No,
Really.
it's not better.
Not really.
No.
It's got to be 1 point something, right? I mean,
1 point
this, you know.
two
but-
something.
What are you guys doing right now? I want to hear from you. So what are we writing now? What are we doing? You take a cue from the last problem. We might write this. It's an exponential form right now,
But I don't write in
and I don't know what to do. But we might write it in log form just to see what happens. Let's try it. It would be log base what?
log base 2x.
What's the base of exponentiation? 10. So it's log base 10 of 17 always equals the power, right? Logs are exponents. Okay. So far so good? We good? Now, on this one, we were done. We'll talk. I don't know what you're talking about. Oh, no. On the last one, we were like done here, right? Because we had x all alone on the right side. But now we still need to do some other stuff here, right? What might you do? How do you get x out of all of this nastiness? We have 2x minus 3 equals something. What do you do to both sides? How are we going to free x? It's just like a
Well, opposite.
add 3. Yeah, so we have over here log base 10 of 17 plus 3 is equal to 2x. And then divide by 2. So we get the log base 10 of 17 plus 3 all over 2 All right, so now we're done, except that's not real nice, right? Like, actually, let's approximate this with our calculator. And the nice thing about this one is, how do you compute the log base 10 of 17? Question. How do we do that? Huh? How do you do it? What was the one we did on the previous slide? Log base 2 of 7? Log base 10 of 17. How do we figure out what that is? Because once we have that, we're going to add 3 to it, and then divide by 2, and then it'll be wonderful. Once everything will be sunshiny after we get that. How do we get log base 10 of 17? Anyone? How do we get, yeah, Jesse? Log 17 divided by log 10. Everyone do that. Go ahead. Did it work? Should be 1 point something, right? Isn't it? 1.2 whatever? Okay.
I said 1.2.
1.2? Whatever. Yeah, he's trying to be supportive.
Right.
Actually.
He's mocking
No,
me.
no, I know it's hard because he normally does mock you. Exactly.
No, he's mocking me.
Yeah, it's 1.2 whatever. So you can do log of 17 divided by log of 10. That works. But it's not necessary. What can you do? It's not necessary. What's the log of 10? You could do ln too. ln 17 divided by ln 10. That's fine too.
1.
But no, you don't have to do that. Guys, log base 10 of 17. That's the button on your calculator. Just do log of 17.
1.2304.
Does it matter whether you divide by log of 10?
Oh no. Nope.
Why? Because what's log base 10?
Log.
Of 10.
1.
Right? So anyway, in this particular case, you don't have to, whatever. Anyway, so figure it out, right? Divide by,
Then
we get,
add 3 and divide by 2.
yeah. All right, so plus 3 divide by 2, 2.115 approximately. Yeah, 2.115 approximately. Is that okay? Can you reason through this? This is tricky. We're not doing like your grandma's algebra anymore. You know what I'm saying? We're not messing around. Doesn't this make you feel smart? I mean, look at this. Look what you're doing. Good job. Let's keep going. See if we can do some log equations before we head out today. Looks kind of scary, right? But I need to share another property with you. Here it is, off in this box. Log base 3 of something equals log base 3 of something. What must be true, you think? Yeah, if I take the log base 3 of something, you take the log base 3 of something, and we get the same thing, then it must mean the things we started with, you and me, were the same. Okay, so given that, and given this equation that we're about to solve, even though it looks complicated, how can you reduce it? What do we have? Yeah, this is A and this is B. And then now, I mean, right? Just solve it. What do you get? Did you get 2? All right, so the bulk of the work here is actually not algebra 2 work. For this particular problem. I'm going to desperately try and see if we can do one more before we go here. Are you ready? All right, here's the next one we'd like to take a look at here. I guess this will have to be our last one. What's this one, ladies and gentlemen? Actually, maybe harder than the last one, even though it looks easier at first, right? I maybe gave it away, though, in the title of the slide.
Writing exponents.
What might you do on this one? Oh, I don't know. Maybe you'd write it in exponential form. because that's what the title of the slide says. I don't know. All right, so here we go. It's in log form. We got log base something of something equals something. So what would that be? 5 to the 5 squared equals 3x plus 1, and from there you can solve that, right? All right, well, the fun and games has come to a conclusion. It's been really swell having you here. I love you all.
Are you doing your outro?